This is me, Timothy, doing my final project for 1011, and here's my setup.
And here are the learning outcomes.
So first off, for the hardware setup, we have the graph kit here connected to my computer, the MOSFET board on the left with the 9-volt battery with the black wire connected to the negative terminal, and then the pump on the right side with the black wire connected to the GND. Then we have the moisture level sensor here with the crossed over yellow and white wire.
For the state machine algorithm, we start off by initializing a delay interval in between watering and a max time variable for the system to run, and the loop will start by checking if the time elapsed is over the maximum time allowed to run, and if it is, it will stop the system. Otherwise, it will continue and check if the button state is being toggled, and if it is, it will override the system and water for 3 seconds. If not, it will check if the delay in between watering is finished, and if it is, it'll check if the soil is very dry, and if it is, it'll water for 3 seconds. If not, it'll check if it's moderately dry, and it'll delay for 1 second. In both cases, it'll update the delay, and then it'll come back to the loop, update the graph and the moisture lever and the button state, and then redo the whole loop. Next, for the functions, we have the watering function that takes in time and graph updates, because instead of completely pausing, we spread out the pauses to be able to update the graph in real time. Otherwise, the graph would just freeze while it's pumping. Next, we have the mathematical function to convert the voltage to a 0 to 1 scale because it's inversely proportional. So we basically take the ratio of the driest value and the wettest value from testing it in advance. Next, we have this the function to set up the graph visuals that takes in a maximum and minimum y value. And next, we have the updating graph function that updates it throughout the loop.
Now for the automatically plotted data, we have the live graph.
And I forgot to mention the signal received in the output.
And we have it watering, almost spilling, and boom, it's high.